And we need to continue, we need to finish the previous explanation. Look at this. What it's about, once again. It's about how to calculate first tolerance. Что тут творится? First tolerance and next accuracy of assembling. And why we calculate this tolerance and accuracy? Above the all, why we calculate accuracy? Accuracy, we calculating, it's called calculation of accuracy. We really calculating error of assembling. We're trying to calculate error of assembling in order to predict results of user future manufacturing. Actually, we're getting not one value, we're getting so-called dispersion of value, field of values, some possible limit of values that may happen in manufacturing. And according to statistical data, these values, they will be distributed, the frequency of their appearing in real life correspond to this curve, to this Bell curve or Gauss curve or normal distribution. It means the close to the middle of distribution, the more often you meet that to another size. The sizes which correspond to the maximum point and minimum point, the farthest points of this distribution, in real sizes you meet the most rarely. And and once again, why we need to calculate accuracy, why we need to calculate error of assembling before we start manufacturing, in order to predict results of user manufacturing. What values of errors we may meet, and what next we have calculated these errors, and what. Why it's important for us? Because people, we have limits, and these limits, they set by designers. I even send you more, as you might see here. Some files already you see, dimensions and tolerances and so on. They are all about the system of tolerancing, or so-called system of geometry, dimensioning, and tolerances. And there are two systems actually. If Your Highness will open these files, you will see that there are systems of American countries, which represented by ASME, American Society of Mechanical Engineers, American Society, Standardization, National Institution standards, and ISO standards. Next one of this, what here is metric system, ISO standards. They have different approaches to, no, actually it's about the same, and it's rather similar. They have little bit different approaches to geometrical description, little bit of someone includes surface roughness into these tolerances, tolerancing, someone not include. Practically, it's all the difference. But deviation of sizes, deviation of shapes, deviation of forms, everything is practically the same in both systems. I sent you to remind what it comes about in order you may refresh your knowledges. I hope you have new knowledges. And all those things you have been studying, do forgive me, in engineering drawing for a couple of semesters. And the whole semester you had discipline which is called interchangeability, technical measurings, and so on. I do not remember exactly how it's called, but I certainly know that you have studied it during the whole semester. Well, also I reminded you, I resent you some more classes of previous groups, and one of yours maybe already even. Oh, I didn't found it. I need to find it. We have already talked also about errors. Here is you see classes of previous years. As I said, compulsory to watch. That one, what these two, part one and part two, it's exactly what we are talking right now about. And even these slides that we have used, they appeared as a result of that class. And plus to this, I have sent you classes of CR basis with 30 years in order you need to refresh what you need. One more thing here, pay attention. This book I hope you will recollect at least what it looks like. And this book, I propose you to read some places, pages I gave you, as you might see. Again, to recollect what you need. Without these basic elementary knowledges, it's very difficult to you to understand what I'm talking about. And you also have one more book. It's our main book. It's our textbook for this semester about assembling. I hope you do remember it. That one. In this book, from the page number 112, please do open and again repeat what you need. Anyway, you need to prepare yourself to the second module at the next week. Well, let's continue. Let's continue, and it means that we need these slides that we have used some minutes ago. Let's stop at this place. Again, what you need to know. Inside of the same assembly method, you are working with method of assembling by scheme, let it be. Not let it be by scheme. We are composing chains. Pay attention to the interesting fact. Why, in my another slides, why you have seen 3 chains. It comes about the same airplane. And if it's the same airplane, all the sizes comes from the same source of sizes for everything. If a digital mockup of fuselage, from digital mockup of fuselage, you are getting sizes of panels, of the fuselage as a whole. You're using this digital mockup in order to create 3D model of jig. Everything comes from the same root. And practically, it comes about the diagram of coordination that you have, diagram of assembling and coordination, which you have in your bachelor work. And what do you see now, like chains of size transferring? It just rotated to the 90 degrees. It just rotated picture of diagram of coordination. Just when you're working in item 233, you are using 2 top chains. When you are working with item 234, you are working with bottom 2 chains. Like with first and second chain, and here you are working with second and third chain. That's it. Calculating here the tolerance limits, as designer haven't given you limits for your unit. He, she, whatever. Designer gave limits only for the aggregate. You need to recalculate aggregate units for the most strict one for your own tolerance. What did I say? Designer gave you tolerance, aggregate unit, aggregate tolerance. To forgive me if I did mistake when I was talking. Sorry. Designer gave you aggregate tolerance, aggregate limits of sizes, and you need to recalculate it to the most strict variant. I hope you do remember this example with box with cubes. Да? In order all the cubes are sticked in the box without any problem, demands for cubes for these components are more strict than demands for the box itself. And you are going to stick in your unit, your rib or spar or something like this, into jig of the wing. That is why you are trying to understand what is the miscoincidence between jig of yours and jig of aggregate that you are going to work with next, the next stage of assembly. You need to calculate this difference, to substitute this difference, like you see, from aggregate tolerance, and then you will see what is your own tolerance, and postpone this. Like you don't use it for some period. Now you know what should be the tolerance, and next step that you are doing, you are calculating the accuracy of assembling itself. So you're calculating assembly errors. Once again, how to calculate assembly errors? Considering that we have that or another method of assembling. Here you see slide method of assembling by scheme. Here you see that we have error equations, which consist of error of jig, error of original base, and error of coordination between jig and part that you're going to locate onto this jig. Plus so-called error others, which are not calculatable. We just consider them as 30 or 40% of the whole error. If you not mind, once again remind you where you study these errors. We have studied in the first half of semester methods of assembly, and we know that each method of assembling characterized with that or another equation of errors, and as a result, that or another value of possible errors, that or another accuracy. I propose you usually to use this one because it's convenient for you, because it's reduce your calculations. And you should understand that in real life, some things that in your bachelor work you're assembling in a jig really are not assembling in a jig by contour methods. Either they assembled by holes or they are assembled at least by CFH technique. Uh, like panels, for instance, they are most typically they assembled like this, especially in the middle of the fuselage, the middle section of fuselage. But next, on the next stage of assembling, they are compulsory finalized with the more accurate techniques. And while using these more accurate techniques, additionally, they use so-called compensation approach. And this compensation, it's resulted in increasing the accuracy with respect to the previous accuracy of assembly units. But it's in real life. In your bachelor work, in order to reduce the difficulties, my proposition is to use the very first technique that you see. Additionally, you will have the shortest equation of errors and the easiest work for you. So we're working right now in frame of this technique. Once again, what we're going to do? We are going to calculate right now. We are going to calculate some errors of either absolute error of object or errors of coordinations according to the formula. This formula we were talking in previous half class, the whole class. We were talking to recollect this bell-like distribution, so-called Gauss distribution or normal distribution. Why normal? Because normally we meet it in real life. Which characterize it with what distribution of errors, describe it like middle of distribution, the middle line. And coordinate of this middle line is designated with Greek letter delta, big delta. And half of distribution, you see it's symmetrical to the left, to the right, to minus and to plus. Half of distribution, the whole distribution width, described as delta Greek delta little, and half of distribution, it's quite clear, mentioned, shown, given, represented as delta by half. Here you have not usual sum, but so-called vector sum. When you have, when you're working with triangles, for instance, you have squares of components, and in order to find some third component or some another component, you need to take square root. Well, let's try to work with one of examples that we see in another slides. But do forgive me, in this case, as I said you, it's difficult for me. It's too much complicated to write in normal mathematical way. Yeah? So what we are going to do, we are going to work with calculator. John absent. Great. And even, I have only Pradiv by now, seems like. Font show me that Brinta present. And let's see who is present here. Brinta and Pradiv. Well, I hope that Brinta and Pradeep, you will help me. But my hopes, maybe I'll be disappointed. Next, maybe. Now, you see calculator and you see these values. Please help me if you not mind. Oh, to be frank, here is mistake. Here is not 0.5 if it comes about template method. One more thing I forgot to remind you that these chains, they are written for that or another method of coordination compulsory. And methods of coordination may differ with approach to jig mounting. Right now we're talking about jig mounting by template. It's so-called template method. And approach to, they are different with origin of coordination. Here you have system, no, the old-fashioned way, and you have system of lofts in this example in order to provide coordination. So the whole method is called loft template method in this case. And let's try to calculate error of coordination. No, at least for the purpose of record. What about middles? Pay attention where you have this red curve which shows something like L, like loop, like letter C. Somehow it's similar to letter C because we're calculating the error of coordination. You see it's designated like C, aggregate of jig, aggregate of unit. Actually, it comes about these values that you see here, but we need to understand how it's work. Should we? Yes. Let's try. About middles. I hope middles you see. All the fields are symmetrical. You see plus minus 0, 2, plus minus 0, 2, plus minus 0, 5. And quite the same in the second chain. What we need to do? We need to write down square root from 0.2. Why 0.2? Because the whole range, the whole field is 0.4. Minus 0.2 plus 0.2, absolute value is 0.4. Half of it, 0.2. And as we're talking about length, not about coordinates. Width is a length, yes? When we're talking about coordinates of middle, coordinates of middle distribution, then it's important to take it with signs, plus or minus. In this case, above the log, it's not coordinate, it's a length. Alena has appeared again, great. Maybe John will come, maybe someone else will come. Alena, if possible, find me Angelic and Yasin. And
Okay, madam, I call.
thank you. Next, once again, this 0.2, no? It's, as I said, you absolute value, and next it will be in square root anyway. Square root, in square, sorry, in square, in second level. You see, how many times you have it? No, actually, we may write it like plus, and again 0.2, plus, and 0.2, and so many times, how many times you meet it? Actually, 4 times. So instead of this record, what we may do, we may write multiply on 4 times. 1, 2, 3, 4, as you might see. Plus what? Plus we have 0.5. 0.5 where? How many times? Here and there, 2 times. Let's close, equal to. And you should remember it's plus minus, as you might see, plus minus 0.81. Let it be. No, exactly like it was calculated here. Plus minus 0. No, we have rounded up to the first value. Plus minus 0.8. And what is it? It's the difference between jig of aggregate and jig of unit. What next? Next, we need to refer to the technical instruction of aggregate. As you are working here with fuselage and panel, it comes about instruction for fuselage. In particular, if we're talking about the central section of fuselage, more probably deviation, limits of deviation of sizes here, plus minus 2 millimeters. For aggregate, for fuselage, in the middle portion, it's given plus minus 2 millimeters. We're substituting this plus minus 2 millimeter from, we're substituting the error of coordination we have got this 0.8. We are substituting from plus minus 0.2, and what we have plus minus 0, plus minus, sorry, plus minus 1.2. According to what we were talking, in order you may recollect my weird example. You see, let's increase the value. Yeah. Compulsories, you see, да? The error of coordination, tolerance for it that we are searching for, that is most important for us. This tolerance for it is 1.2. And what is it, this 1.2? It's a value that we are going to use for comparison. It's a value that I said, now we have calculated it, we're quite happy, but we postpone this value. We just do remember this value. It's tolerance to be compared with, but we are not working with it now. We comes to the next item. Next item, 2.234. А что здесь два раза вот это вот написано? Что попало вообще? Next item. Next item, 2, 3, 4, as I said. And now we're going to calculate the error of assembling. Ну что? That's great. We are going to calculate the error of assembling. Let's designate it with lately another color. Error of assembling for considered assembly unit and compare it with unit tolerance. So technique is calculation will be very similar, but we have two different values. One value is limit for our possible mistakes, let it be unit tolerance, and another value, error of assembling, it's our prediction, it's our forecast for results of our manufacturing. Let's go to calculate. How we're going to calculate it? No, that one, I hope you already understand. That one. Once again, we need to recollect what is assembly method. Assembly method is by scheme. We need to understand what is the error of equations. Equation of errors. We see it. Equation of error consists of error of jig and error of coordination between jig and scheme contours. For this, it means that we need one more system of auxiliary chains. Here in this slide from our lecture series, no? You see there are two chains, and both of them again have started from the same system of lofts. That is why I propose you normally to draw three chains simultaneously somewhere. If you don't like to insert it like this in your bachelor work, if you'd like to see it in traditional way, like two chains and two chains, let it be, but somewhere in your papers, do compose 3 chains at once, and next do work with these 3 chains, please. In order you do not mix up what you are working with. In each example that you have seen today in these slides, what you have seen, that each time we are working with 3 chains, but we use it either first, second, when we are talking about 2, 3, 3 item, or we use it second and third when we are working with 2, 3, 4 item. What is also important to understand, to remember, pay attention. Here, even with colors, all the hints, let it be creeps for you, they are given with color. Look, error of error of the jig, green line. It means that you are passing along this green line. Error of jig. Error of coordination, blue. Error of coordination. And we have so-called coefficient of fixation. Coefficient of fixation is given in your laboratory manual, and these things that you can't see on your own, you may only read it about, and you may to know it from us. When we assembling something in a jig, in our very first lab, we usually do an experiment when you are measuring with indicators accuracy of assembling depending on how many clumps you have. And of course, to see the tendency, it's necessary to measure some hundreds of points. But anyway, it's visible that as only you closing or opening one of clamps, all the system of clamps resulted in some accuracy, let it be. But as only you open or closing one of them, accuracy is changing. To the plus, to the minus, for us it's not important. But certainly it's changing. So amount of clumps affects the accuracy of assembly. That is why it's included into such calculations. Now, moreover, I hope it's not difficult for you to imagine no, that this distance between our outer surface of skin in a picture and outer surface of locator, which appeared because they are not ideally manufactured. That is the difference appearing reason. This difference it may be reduced by applying the clamps, which will narrow this clearance between outer surface of skin and outer surface of locator. And because of this, skin more accurately will repeat locator. And I hope you do remember that jig is, on one hand, it's produced more accurately once. Yeah? It's produced once and more accurately than some hundred of skins. Moreover, when we are trying to repeat the surface of locator, we increasing interchangeability of these panels of the skins because they are not so different any longer. They are more similar, not even to theoretical outline. Yes, maybe this locator is not ideal. It's not ideally repeat theoretical outline, but at least next all the skins will be more similar to each other, more interchangeable. And in terms of coordination, it would be better. I hope you do remember this story that we have started to study since the third year, that to provide assemblability, it's not compulsory to have 0 errors of objects. It's not compulsory. It's enough to have equal errors of objects. If errors are the same, the error of coordination is 0. Now, of course, both of errors of these objects, they must be, of course, inside of tolerances. But anyway, let it be some errors, but let it be these errors are equal. And that is better in terms of coordination, in terms of assemblability. So when we are attaching skins to locators, we not only increase the accuracy of these panels, of these aggregates, as a result, next, of the unit and of the panel, of the aggregate, I mean, the whole fuselage, but we also increase interchangeability of them. Well, let's come back to calculation. And what should we do? in terms of calculation. Once again, we have already identified that we going to calculate error of assembling along this line, error of jig along this line. Next, we're going to calculate error of coordination and multiply it onto error on coefficient of fixation. And next, we are going to add one more component, let it be, of this equation, which equal to 40% of error of assembling. What does it mean for us? It means that when we calculate these two values, we as we decided that is 40%, it means that this is 60%. So we're going to summarize them, divide it onto 6, multiply it onto 10, and as a result we have 100%. Well, what we have in slides? Do we have calculation example? Yes, we have. Pay attention. First, we need to calculate error of jig along what you see top line. Next, you need to calculate. No, in this example, colors are different. Whatsoever, we are going to use these slides right now. And finally, calculate the sum and multiply this sum up to 100. No, you see the different errors. And next, has appeared the pictures at the bottom which overlap the now they disappeared. This error other, what originally you have plus 0.72 minus 0.62 plus error other. And finally, the values are already greater because we divided on 6 and multiplied on 10. Well, let's come back to slide. Let's come back to calculator and let's try to repeat results that you see at the bottom. Maybe it will be some other results, not for sure. I need to see more. Let it be like this. I need to see the whole slide now, since beginning. Why? Because in this case, when I'm calculating error of the jig, I'm going to calculate it from this place, from point which is very first. Very well. First, needles. All the fields again symmetrical. Plus minus 1, plus minus 1, plus minus 2, 2, and plus minus 5. Along these lines, all the fields are symmetrical. It means that I have 0 plus square, no, plus minus actually should be, but I'm not sure that it's possible. No, of course, no such sign in calculator. I hope you understand it. Да? Like plus minus, it can't be. 0 plus square root. Что-то я как-то мне уже и страшно, тут уже слишком много всего. Simple mode. Let's increase it. Like this. Да. Square root from 0.1. 0.1 in square. Да? How many times? I see it twice here and there. Multiply it into plus next value 0.2 and 0.2. 0.2 square multiplied into plus and until we do not pass all the chain 0.5. 0.5. Wait, I forgot to insert plus square, and we have finished the chain. You see, everything has finished. What is the value? Plus minus 5, 9. Да? Wow. Why? Here it was another value. Maybe I did mistake. Wait a second. No, no mistake. I'm not seeing any mistake. It means that I made mistake here when I calculated the slides. Square root. Clean everything. Square root of 0.1 square plus 0.2 square twice plus 0.4 square. I made mistake here. Plus minus, when I will rewriting something, I make mistake, certainly. Plus 5, like this. Next I need error of coordination, and in this case task is already complicated. What is complicated with? Let's come back to the previous. Let's come back to the previous slide where we were talking rather long in previous class about characteristics of this fields of distribution, and I hope you understand. I hope, sincerely hope you understand that distribution characterized with the coordinate of middle and dispersion width to the left, to the right. And each time when we are working with this formula, first we need to think over where these middles are. Look at look at look at this slide that we are working with. We need to see, we are taking into account only these fields that correspond to this blue loop, and we need to see whether we have all the fields symmetrical. Symmetry, 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 symmetry. No, not symmetrical. 0, minus 0, 1. It means that middle of this field is minus, it's important, 0.05. 0.05. It's a field, middle of field, which responsible for transferring the size from sand mold to bending punch. Because it's made by casting, it's non-symmetrical. Next, bending punch. Oh, it's also bending. It's also somehow casting. You understand that? Because when you bend something on the bending punch, you can't penetrate inside the punch with the metal. It can't be. No, of course, if you haven't spoiled the punch. Next, here we have field which is also not symmetrical from 0. I have changed this already in the previous class. How these silly mistakes has appeared again. Maybe I have not saved the slides. Да. It can't be minus 0 plus 0. Ну, бывает. What is the middle in this case? Во-первых, at the first, it's plus, and this plus is 1.5. 1.5. In order you may understand that it's different place, now we place it into brackets. It's a sum of middles. Altogether it will be plus 0, plus... Господи помилуй, что я делаю? 0, запятая. А вот тут надо убрать запятую. Sorry. Going crazy, going mad. One step by step, as you might see. Minus 0.5 plus 0.15, да? The half, the middles of these fields. And altogether it's resulted plus 0.1, plus 0.1, plus square root out of which values? Look, no, 0.2 here, you see how many times? 1, 2, 3, 4, 5. So let's write down 0.2 square 5 times. Plus what? Plus you still have this one, symmetrical, plus 0.5 minus 0.5. So you have plus 0.5 plus what? This value. In this value, half is 0.05 without sign. Doesn't matter. Minus, plus, anyway it will be squared. 0.05. 0.05 square plus what? That one. Half of it from 0 to 0 to 0.3. square, close the bracket, equal to. What now you have got some value. Pay attention that that I made it wrong. Look, upper deviation is with sign plus, but also we have minus, plus minus, да? Minus lower deviation, it's like this. And what you see here, this record, it corresponds, pay attention, да? It's what we were struggling for preliminary. I hope you do understand what I'm talking about. Да? It's the same representation, but in different way. This plus 78 and minus 58, it may be represented as plus 0.1 plus minus 60, no, 8. Why it's 9? Because you see 78, 9, and so on. When it's rounded, it will be 79 and 59. So here it's another representation of the same thing. Because when we are using the formula, I hope you do remember, we must use formula in the way, oh, here is, да? Over the calculator, you see, sum of middles plus minus vector sum of halves. Now, let me use paper, sorry, not in front of you, sorry once again, sorry. Plus minus 0.4, plus minus 0.59 plus. Why I use this 0.5? 0.5 because I think that I have 4 clumps. If I have 4 clumps, I open the book and I say 4 clumps. It means that error of coordination will be twice less. Coefficient of fixation is 0.5. The more clumps, the less this value of coefficient of fixation. It means that you will have more accurate G, and less amount of error of coordination is included in the general error of assembly. Wait a second. So plus 0, what upper deviations, plus 0.59. We even will copy it right now. And instead of, I will try at least, where we have white. Да, that one. А что это такое? Tolerances. In order to calculate it in front of you. Да. But instead of this plus error others, да? Instead of these plus minuses, you will see top line and bottom line. What do I mean? Upper deviations plus, да? Plus what? That one, this blue one, I may write down in another way. What 1/2 of this one, it will be 0 plus 0.5. And 1/2 of this one, it will be, instead of this, plus 3, like this. And it means that we may round it like this. I hope it was clear. And plus error other. What about minuses? This place, green one, minus. At this place should be again minus. Ёлки-палки, что трапилось? Minus that one, minus 0.08. What about this place? Also minus, oh, sorry, I'm wrong. This place is plus. I'm wrong because it's plus, да? And you see, next you see plus to the plus, it's give plus, and plus to the minus, here it's give minus. Here is plus, here plus, minus. I'm wrong. And now we need to calculate the final value. Калькулятор. Ну, зачем нам калькулятор? Это и так видно будет. Сейчас равно. Да что ж ты делаешь, Хуликан? Ctrl-C. Ctrl-V. What it equal to? Look, Z1 is 0.4 in this place. Yes. And here 59, it means that we have 0.99. Вот так. Not red one. It's not red one. Some another way. Вот так. Some color. No. 0.99. No? What about this place? Look, here is plus 0.5 minus 0.34. So altogether it will be like this. So in plus it will be plus 0.9, minus it will be minus, oh, I forgot to change color here, minus 0.9. No, here is practically the whole millimeter, plus millimeter, and here minus 89, less than millimeter. But now it's not the final value because we have here again the same story, plus error other. Plus error other. So we have not finished it yet. I hope you understood it. How may we finish? Why they are different in length? Not obvious for me why they are different in length. No, let them be. Да, accumulating of errors. Well, now let's try to recollect this plus 0.99 plus error others. Once again, 40%, 60%, 40%, 60%. I remind you, no, here it was 70%. No, up to you. Depends on you, and really it depends on type of unit. Depends on no, let's say technological tradition of your enterprise, which will be resulted in then or in other statistics of your enterprise. And let's write down the final value that we have. Calculator. Pay attention. Here you have 0.99. 0.99. Look, in order you to not mix up, multiply on 0.6, divide on 0.6. You should divide on 0.6. Look, and you have final result. No? In order you do not such mistakes. It's easy to remember. Now you are. Now you see 60%. How to see 10%? That one divide on 6. How to see 100% if that is 10%? How to see 100? Multiply on 10. Finally, you see it. No, values are the same, as you might say. So at the top here, we have finally what we have as a result. Plus 165. And at the bottom, finally, what we will have? Calculator. Minus 148. minus 148 millimeters. In both cases, it comes about millimeters. Millimeters, millimeters. Do you remember what we had when we calculated tolerance IF ratio? Not. And let's copy this piece of screen now. No. In order to insert in the place where we have print screen. Did I say it? Print screen. Ok. Ok. Computer what was doing. Look. Here is the place where we have calculated tolerance. And what we had as a result? Look. Tolerance limits of designer plus minus 0.2. Oh, plus minus 0.2. Plus minus 1.2. And what we have done finally? Извини меня, пожалуйста, своим поведением. Так. So, your opinion, is it good or not, what we did? Does it correspond to demands of designer? Or we should change something in manufacturing? Brinta, Radif, Azhelik, your opinion, please. You see that possible assembling give you results wider than tolerance. Is it appropriate for assembling, or you need to change something in manufacturing? Brinta, do you hear me? Very well. Then answer the question, please. We are comparing what we have got with demands. Demands, red color. Tolerance that we have calculated, we recalculated aggregate tolerance for our own tolerance, for tolerance for the panel or for the rib, whatsoever we're working with. We recalculated it, and we see that demands of designer to assemble this rib, to assemble panel, rib, spar, not worse than plus minus 1.2 millimeters. After we have calculated accuracy, assembly errors, after we made next step of calculations, that one, it's appeared that possible dispersion of sizes of real objects is like this. What should we do? Seems like either around 30% of our assembly units will be just spoiled because after you use it for assembling the wing, the whole wing will be wrong. So you can't use these assembly units. Or you need to change something in your manufacturing. I hope you do understand already, in order not to waste neither my time nor yours. You understand that if this value is greater than this value, and it's greater, you see that 165 is much greater than 1.2. 148 is much greater than 1.2. You shouldn't use this technique of coordination in this case. No, seems like after our calculations, we see that assembly errors are out of tolerances. Some objects, but really some objects, maybe the good portion of these objects, around 70% or 60% will be inside of tolerance, but other would be somewhere far outside of tolerance, like this. And you can't agree with this. It means It means that instead of this technique of coordination, with using of lofts, with using of template for mounting the jig, you need to use something else. You may change approach into two different ways, at least in two different ways. Above the all, it's not compulsory to use lofts as the origins, the first origins of informations for your object. And what do we normally do next? What do? We change it into so-called program method. Second thing, also important consideration, it's not compulsory to use even mockups or templates for your mounting the jig. Really, maybe I already said it to you. Really, these values of what I wrote here, plus minus 0.5, they are reduced values in order not to scare students with real values. So when we use templates as mean of mounting, these values will be even greater. For flat units, for inner units of airplane, like frames, like ribs, especially for the ribs that you have, which has compensators and do not touch the contours of the wing, it's quite enough to have such accuracy, because next you're going to compensate it in real life. But in your bachelor work, of course, you're considering that you need to do everything is inside tolerance, and it means that it's not appropriate to use this technique of coordination. So we staying at the same assembly method, we still are inside of assembly method of skin, but we are changing the approach to coordination. Look at this. Now, instead of skin of panel, jig of rib, great. Почему в panel? Skin of panel. Так, jig of panel must be then. It's some mismatching. Maybe I was talking to students, and on the way we just changing everything, and altogether it's resulted in very weird things. You see? Да. Not skin of panel, but cap of rib. Then cap of rib. What is the difference, by the way, about these two slides? This one and that one. Pay attention in the middle here, at this place. Difference is hidden here. You see, practically it's all the same, but no, except of mistakes with these ranges of errors. And you see the differences here. It was what it was about. Look at this. Let's start with the spa first. Let's see that John is absent right now. John is absent. Yes, John is absent. Once again, let's repeat, no, at least quickly repeat the same things for this another diagram of coordination. You see here that we are going to use another system of chains, but we are going to use the same. Let me copy down this objects. The same approach. Oh, you see, brilliantly work. First, we need to calculate the tolerance. Now, above the all, chains are different. Chains are composed in idea that you have. Don't stay here, please. That you have another techniques of coordination. And if we're talking about another technique of coordination, we have another sequence of size transferring. Sequence is different. And we have another values, these values of distribution of sizes, errors between that or another object. What do we see? When we're talking about this same 3D model and 3D model, 3D model of wing, 3D model of jig for wing, inside the same computer system, it's zero. No, I hope it's obvious for you. Next, when we are generating the program from this 3D model, as you might see, maybe something is changed in this case. And this something, no, I mean some error has appeared. This something is very little, really. Program, this accuracy of program, you may check in description of system itself. These values that we took here, they are rather realistic, but they are not corresponding to some real system. So it's given in documentation for your software, what is accuracy of program generation. But that program that generated in G-code, so-called for CNC machine in general, next must be recalculated by machine inner computer, which is called post-processing, into another program which is appropriate, which is suitable for this particular machine. And at this stage, you also might have some losing of accuracy. Look, I wrote here some value. Approximately, it's like level of values, extent of these values is of such a way. But again, it's necessary to open particular passport documentation for CNC machine and check it here. And the same is with accuracy of machine itself. Here it's written 0.1, but it may be less, it may be worse. It's necessary to check in passport of particular machine. What is next? Next, what will happening here? You see that you have jig of wing and next program CNC. What they will do? They made locator, fixing arm of this wing jig. They cut it in CNC machine. Next, this locator was placed into beam. We are not writing here beam. We're writing here instrumental stand in order to emphasize that beam, the skeleton of jig, was produced in instrumental stand. And accuracy of instrumental stand rock is plus minus 0.1 millimeter. And next, when you combine this contour locator with skeletons that you made, like final stage of mounting the chip, with skeletons that you made in instrumental stand, this combining of all the elements of jigs together, mounting of jig, might have accuracy up to 0.2 millimeters. Here is the same. You see that we pay attention what jig of spa, and you see that and you see that we have here again wing, 3D model of spa itself, 0, 3D model of spa jig, 0, and next it's very similar story because we are working with spa. Jig of spa we are going to assemble using instrumental method, instrumental technique. So quite similar chains, differ only with their, remind me how it's called, quite different chains which are differ only with names of jig and name of locator. Here it was contour locator of wing, here is contour locator of spa. Jig of wing, jig of spa. Now we need to recalculate the value of coordination error here. What is value of coordination error in this case? Pay attention. 0.1, 0.1, like this, twice. Next, 0.5, 0.5, вот так, 0.05 twice. And altogether, let's do it a bit less in values. Or it stopped jumping. 25, for instance. Inconvenient system for me. It's inconvenient. I'm not insist it's really inconvenient. It's not convenient for me. Next, you see 0.1. How many times we need this 0.1? 4 times. Here, there, there, and there. 4 times 0.1, and 2 times we have 0.2. Now we need to recalculate the value. Let's call calculator, come here. Так, and forgive me, I would better refer to the chains themselves. Clean 0.01, oh, sorry, clean square root. We need plus minus square root, yes? Above the all we have 0 here. What? 0 because all the fields are symmetrical. Plus minus square root of. Under the square root we have 0.01 twice plus 0.05 twice plus 0.1 2 times plus 0.2 2 times. I hope I haven't mistaken anywhere. 0.1 2 times 0.5 2 times 0.1 4 times 0.2 2 times result plus minus 35. No, 3538. Now you see plus minus 0.3538 like this. It was our error of coordination between jigs. In preposition that we still need unit tolerance to calculate, what will be delta Z1? No? What will be this tolerance for unit in this case? I hope you do remember. That unit tolerance in our case will be equal. Oh, sign plus minus. And unit tolerance, it's our red colors. No? Unit tolerance is plus minus 2 minus this value. And in this case, unit tolerance equal to, what is equal to? Help me. Thank you for your help, people. Do pay attention. Previous time, when we were talking about, oh, now it's recolored everything at all. How it's look? I do not understand. Так, let's try once again. Unit tolerance, red. Unit tolerance, red. Why? Because we had here error of coordination like this. Error of coordination between two jigs, plus minus 0.35. So if we think that we really, it may be different. It depends on the aggregate. I hope you do remember. If we think that we have the same demands to aggregate tolerance, that we see that our unit tolerance is plus minus 165. just because we changed technique of coordination. Another technique of coordination, and you may spend more. If we come if we come back to the silly example, look at this. The same salary, yeah, and compulsories. If you live in more cheap place, if you pay less for rent, if you live immediately in office, for instance, and you don't need to get some transport, no, to get into office, to pay money for transportation. It means that here you have more. With the same salary, you have more opportunity to spend to food, entertainment, creating the family, education, whatever. Well, let's come back here. And here we need to recalculate now error of jig. Let's recalculate error of jig here. It's not difficult at all. I hope you already understood how we're doing this. It's not the sort of trick for you any longer. Look, we need to pass along this way, and passing along this way, what do we see? All the fields are symmetrical above the wall. It means that we have 0 plus square root. 0, next under square root 0.05 once. Here plus minus 1 plus minus 1, 0.1 twice. Oi, I forgot to insert plus here. And plus 0.2. 0.2 square. So we see it plus minus 25. Plus minus 25. Plus minus 25. And what about the error of coordination? Error of coordination equal to, pay attention that in case you are producing bending branch and CNC machine, you see symmetrical field instead of what we had before. And unsymmetrical field is only here. So here we have 0.15 plus square root out of what? And now we have to work with error of coordination. Which values we have? 0.01, 0.01, and twice here and there. Twice. Plus 0.5 here and here. 0.05 square twice. Plus 0.1, 0.1, 0.1 plus minus 0.1, no? Thrice. 0.1 square thrice. Plus 0.2 square plus, and here you have the whole field is 0.3. It means that half of it, 0.15. 0.15, like this, equal to plus, I forgot to do one more thing again. Let's come back here. You see plus 62.46, yeah, to the top. And if, let me to divide this. Now, if I'm talking only about square root equal to, here we have 15, так? Oh. 15, and here we have plus minus 47. Plus minus 47. And next we need to repeat the calculations. Let's try to do it once again like we did it in previous time. No, here. I hope you do remember what we were doing. Well, we have big enough, yes. We have this value and we need to recalculate it. Wait a second. It's behaving like crazy when it's transmitting between different elements. And let's calculate. Plus. Да что ж такое? Что ты ведешь себя безобразно? Не единообразно и совершенно безобразно. Ctrl-C. Plus 20. My fault. Plus 0.25. Plus, if we recalculate this place, what do we have? Plus 0.75, like this. Plus 0.47. No, and plus error other. That one. So, what instead of this 0.4, we are writing. Ой. Ну что ты делаешь? Кыш. Plus error other. Plus error other. Now about minus line, да? Minus 0.25. Plus this middle, it's anyway plus. Plus this middle and minus 0.47. And let's calculate what it equal to in both of cases. Sorry, not 47, not 47. Oh my. 2, 3, 5. Half of it, I forgot. 2, 3, 5. You just have seen how it's appeared. That is the work of human factor, as it called in manufacturing. Да? How mistakes may appear. Equal to... Что такое? Equal to... What is equal to? No, that one, 75, 35, it's 31, it's a period. No? Let's use calculator. Considering how great I am in making mistakes, better use calculator. Plus 235. Yes. And plus 0.25. So it's plus 0.56 plus error other. Like this. In millimeters. And what about minus? Minus value. Minus. Calculator. 2, 3, 5. But look. Plus 0.75 minus 0.235 equal to, да? You see, minus 16 and minus 25. Minus 41. Here is minus 0.41. 0.41 plus error others. Now let's try to increase it up to the final value. How to do this? Easy peasy. I hope you do remember that it's really easy peasy. Look, this minus 41, if we consider it's like 60%, divided on 6, multiplied on 10. Minus 68 3, да? Minus 0, 60, 68. What about this value? 56, 0.56. Oh, sorry. 0.56 divided 0.6 equal to 933 plus 0.9 millimeters. Great. Is it the same, you think? Oh, what after? No. Now let's take the piece, print screen, and let's compare to the value of tolerance that we have got before. Now you see, I hope, that above the O, tolerance we have more wide because we changed the unit coordination approach. No, not only unit, but aggregate also. We have changed it from lofts to techniques that use digital mockups, CNC machines, and so on. And also we have changed the means of coordination. It means that how we're going to mount the jig, we change it. It's maybe resulted both in increasing and in reducing of coordination error by the word. No, in this case, we're lucky to see that, at least with the values that we have written in chains, we see that unit tolerance in our case is greater than possible assembly errors. And it means that this system of coordination you may recommend for manufacturing in this particular case. So last step that you should do after you calculate unit tolerance, which you're going to compare with, after you calculate assembly error, which in case of assembly method we used consists of error of jig and error of coordination, no, plus error others which are not necessary to calculate practically, nothing to do with. Next, last step is to compare the tolerance, your limits, red color, with obtained values of possible dispersion of assembly errors. In case limits are equal or more than errors, you may use it in manufacturing. In case, like it was in previous case, limits are more narrow than possible dispersion of errors that you're obtaining in manufacturing, that you will obtain in manufacturing. In this case, you strongly not recommended to use this technique of coordination or these assembly methods. Or you should be ready to opportunities that you are spoiling your money and time. Around 30% of, according to what I see, around 30, no, 30%, that's over still. Around 1, 2, 165, 40, not 30%, more something close to the 20%. According to this bill distribution, something around 1/5 of assembly unit will be spoiled, or they will be out of tolerance. What else you might have seen in my slides? Yeah, no. Another technique of, wait a second, switch on the panel. It's switched on, it's just hidden. Oh, да. Panel. This panel. What else you have seen? Pay attention to the case that we have considered right now with this part. And when both of jigs being produced in instrumental stand. Being produced not in instrumental stand, but using instrumental stand. You see, in chains of both jig of wing and jig of spar, you have instrumental stand and locator made in CNC machine. But if it's like it's rational, it's convenient, it's feasible, let it be, when you have complex assembly unit, especially when it comes about the GPH locators, you need imaging. For instance, in a SPA you have brackets, you might have even need jigging plate. In this case, anyway, you need to use instrumental stand, at least in order to make a gauge of junction. For wing, yes, compulsory, you need this instrumental stand. But for inner elements of wings, like ribs, maybe you don't need it. Maybe it's too much complicated. And here you see combination. This combination, originally it was started here, explanation. Combination when you use at the top line, you use, it's called program instrumental method. And in the middle line here, you use so-called program template method. When you use template for mounting of jig, but instead of making this template from system of lofts, templates also made from 3D models, from digital mockups. The difference is that, once again, that in this case, you don't use complex, expensive, and awkward, let it be, technique for mounting the jig. You use the more primitive technique. Both locator of contour and templates may be produced by using programs, CNC milling machines, and so on. No, normally, of course, we have program different here for contour locator and for template of jig. So here it will be even more complicated chain. But for students, we simplify it. Let's think that the same CNC machine using practically the same program, cutting both template and contour locator, maybe simultaneously. But because they are two different objects, actually it should be considered somehow. Yes, that we have here additional chain, additional loop. And this chain, it's usually, you see, it's counted, included like this. Like you have here two steps, you might see. That? And but to be frank, I made mistake here. Instead of double value here, it should be double value at this place. Right now I will change it in order in the movie that we're making together. I mean this record. We have correct value. Plus minus 0, 1. Plus minus. It's funny to see how many mistakes even me may do. No? And what should we say about our poor students? Да. Ну что? Including the classes that you have before about explanation of how to calculate the errors. You have even more than all the previous groups altogether. I mean, in explanation. Couple more slides I need to add. I will drop you I will not recalculate right now the same things like we did it together with you. I mean, I'm not going to recalculate these values for the case that you see in front of you. We will stop at this point. But, Your Highnesses, later I will send you photos of this together with a record of this class. And I hope I will send this record not later than tomorrow. Stop the record.